Okay, question 6. Now, this question is important because I have seen a lot of questions in TYS in school paper where involve multi-bodies rotating a circle. So you have to know how to do this question. All right. So the first thing you need to understand is that we have different radius here. And they're all rotating with uniform angular speed. So it's already written here. Uniform angular speed. Which means that they rotate together as one single body. Three bodies rotate together as one. Okay? So with this, in terms of, let's say you are looking at the top view. So your eye is here, your beautiful eye, looking downwards. You should be seeing something that looks like this. A, B, C, moving around in a circle. And it's important to take note that the angle in which they cut, the rate is the same. So your d theta over dt is a constant. And it's same for all bodies. All right. So these are the few fundamental concepts to take note when it comes to solving questions like this. Okay. So when they say determine the angular velocity of the three balls, all right, a lot of people think that, hey, I need to find angular velocity for ball A, B, and C. Actually, the thing is this. Omega A, let's make a capital A, is equals to omega B is equals to omega C. So therefore, you only need to find one. Then you found the others. So how do you find one? The same thing applies. This is your V for what? For which ball? This is your V for which ball? A. Okay, so you can find omega A. This 3 meters will be the radius for which ball? A as well. So what formula has V as R as omega? V equals to R omega. Okay? So straight away you can put the numbers inside. It's all substitution. Then you will have 2 radians per second. It's important to take note that angular velocity is radians per second, and always check for SI units. All these are in meters per second, so we are good. There's no need to convert. And that's how you do for A. Now B is going to be a bit complicated. Okay? So how do you solve for B? So I'm going to erase the solution first for A, so I have more space. We're just going to put 2 radians per second here. So for B, right? What have you solved? You know the speed of A. All right, the linear speed of A, you know the angular velocity. Okay? if they ask you to find the tension in three parts of the string, now the tension is it the same? Actually, it's not. Tension A is not equals to tension B, is not equals to tension C. So again, that's a basic concept to understand. Now, the reason being is because the tension provides for the centripetal force, mv squared over r. If your r changes, your T will change as well. Okay, if your V changes, it will change as well. Should we be using this equation? Probably, I mean, it's doable, but if we got angular velocity, maybe we don't need this. Okay, let us switch to another one. We can be using mr omega square. Okay, we're going to be using this. Now, take note, you can use the two of them, but this will be easier for you.
Okay.
Okay, your R changes, and therefore this will cause your T to change. If your R changes, your T changes as well. Since the R for all three balls are different, even though they're all the same mass, their T's should be different as well. And due to the fact that they are connected together with strings, okay, the forces acting on them are different. Okay, so we are going to consider free body diagrams for each of the balls. Since we know A, we should start with A. Can you tell me how will it look like if you were to draw the free body diagram of A? So if you look at the side view, this should be what you should be drawing. O is the center of the circle. Now we are looking at side view. A only has one force, tension. Now, do we consider the weight or the normal reaction force? The answer is we don't have to in this case because we are only considering for direction in the horizontal portion. The reason being is because that's where your FC is acting along. So over here, the TA, okay, can draw an FC inside as a guide. The TA provides for the FC. Once again, FC is not a real force, it's a net force. Okay, you can then put all the numbers inside using the equation. So this is 0.1, R is 3, and omega is 2. You got to square it. And that gives you the answer for TA. Okay, very crucial. Students get stumped by this very often. So your understanding of free body diagram is important. What's your answer for this?
4.2.
And what is a unit? What's a unit for tension? Newton. And then we are done with this. Okay?
So like we only have to calculate TA.
We have to calculate for all B and C as well.
Oh, okay.
Like I said, they are not equal. For the first part, for A, they are equal. So you have only one answer. For B, you have 3 different answers. And if you look at the keywords, right? They say for A, determine the angular velocity. This is a singular noun. Tensions, there's an S there, this is plural. So these are plural nouns, means that you need to calculate for all 3.
Yeah.
So looking at the different keywords will give you the idea. Okay, so this is the first one. So we keep in mind 1.2 Newton. You need to calculate for TB now. Now, how do we start? Always start with free body diagram again. For TB, for ball B, what would be the free body diagram? How will it look like?
The same as A. But
Eight.
then there's the spinning, but then there's also a force from the left.
Yeah. There's a force on the left. This force is what?
Actually,
This force is actually TA. Because it's connected to A. Why is this force TA? Because the tension in the string, if you look at the string itself, okay, these two tensions are actually the same.
Okay.
They are equal and opposite in direction. Based on what? What concept are we applying here? Newton's third law. Okay?
Yeah.
For every force exerted, there's an opposite and equal reaction force produced. So if TA is being put by B, if A is being put by B, B is being put by A, by the equal amount of force, except in the opposite direction. So therefore, these two forces are the same. So therefore, you can put TA here. So this is Newton's third law. The application of this is important. All right. So over here, you have your FC. No, this is not your FC. This is your TB. And then the net force would then be your FC. So with that, you can then come out with your Newton's second law equation. And what is that going to be? How will it look like? So take note, and if you specify FC to be here, towards the center of rotation, your FC is thus the positive direction.
Yeah.
For Newton's second law, this is a very good convention to keep. So your FC is towards the right. Anything towards the right is then positive. So you go with TB, because TB is towards the right as well, so this is positive. Your TA is negative. So TB minus TA is then equal to FC. Your TA, what's the value? 1.2 Newton, so you need to keep that in mind. So you have an m/r omega squared here again. Now, what's the value of your R in this case?
2 meters.
2 meters. Because you're looking at B, which is 2 meters away from the center of rotation. Your omega is 2.
Yeah.
And your A is 1.2. Can you solve? So, solve for TB and get the answer out. Okay? So this question, actually, there's a lot of steps involved for finding ball B. Ball A is the easiest. You should start with that. Ball C also works the same way. So once you found the tension in B, between B and C, you can then find the tension in C.
Yeah.
Or you can just find C directly, since you know the m/r omega squared. So quick, I'm going to accelerate a bit to show you what I mean. So once you found the tension in B, right, if you draw free body diagram for ball C, it should look something like this. TCTB, FC is over here towards the center. Okay, the equation should look something like TC minus TB equals to FC. Then you can find your TC because you know your FC and your TB. So, and you can solve. So that's it for this question. Give it a try, get the answers out.